Hi students. In the previous classes we discussed the earlier attempts to classify elements, that is the Dobriner's triads, Newland's law of octaves, Mendeleev's table. And today we are going to look at modern periodic table. In 1913, English scientist Henry Moseley proved that atomic number is a more fundamental property than atomic mass. Atomic number, as you know, we used to represent it by capital Z. The modern periodic table is based on atomic number. The modern periodic table takes care of three limitations of Mendeleev's periodic table that we have already discussed. Modern periodic law. The modern periodic law states that the properties of elements are a periodic function of their atomic number. Position of elements in the modern periodic table. The modern periodic table has 18 vertical columns known as groups and 7 horizontal rows known as periods. And these elements are also grouped as S block elements, D block, P block elements and F block elements. Group 1 and 2 are included under S block elements and group 3 to 12 are called D block elements and group 13 to 18 are called P block elements and the lanthanoids and actinoids are called F block elements. It is the modern periodic table. Here you can see 18 groups and 7 periods. And you will notice something interesting, that elements with atomic number 57 to 71 and 89 to 103 are put separately below the periodic table. This is done to compact the periodic table. The elements 57 to 71 are called lanthanoid series because they start with the element lanthanum, and these elements are rare earth elements. The elements from 89 to 103 are called actinoid series because they start with the element actinium. These are radioactive elements. Here on the right hand side of the periodic table, you can see non-metals, and on the left hand side, you can see the metals. And there is one zigzag line you can see the left side on the right hand side of the periodic table. Here that zigzag line, the metalloids lie along the zigzag line. Metalloids, as you know, they show the properties of metals and non-metals. Group 1 elements are called alkali metals because they form strong alkalis with water. And group 2 elements are called alkaline earth metals because they form weaker alkalis when comparing to the first group. Group 13 elements are called boron family because boron is the first member in the group. Group 14 elements are called carbon family and group 15 elements are called nitrogen family. Group 16 elements are called oxygen family and group 17 elements are called halogen family and group 18 elements are the noble gases or inert family. When we see the electronic configuration of group 1, here you can see the elements such as hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. And its atomic number also you can see. When we write the electronic configuration of group 1, you can see that in hydrogen only one electron, that's why in the first shell it will show only one electron in its shell. And for lithium, 2 shells are there. In K shell 2 electrons and in L shell 1 electron. And for sodium, the electrons are distributed in 3 shells. The electronic distribution is 281. Here you can see one interesting thing that these all elements belong to, these three elements belong to group 1, and here they all are showing the same number of valence electrons. Here the number of valence electrons, okay, what these elements have in common when we see, they have just one electron in their outermost shell. That's called the valence electron. Here the valency of all these elements that belong to group 1, that is their valency is 1. And the chemical properties depend on the number of valence electrons, which is same for all these elements. Like that, when we move to second group also, we can see the second group elements will also show the same number of valence electrons. When we see the electronic configuration of group 17, here the group 17, the first element is fluorine, then chlorine, then bromine. First three elements are given here and its atomic number is also given. And the electronic configuration of fluorine is 2,7 and that of chlorine is 2,8,7 and for bromine it is 2,8,18,7. And here also you can see that their valency is same. Valency is same. That is 1. Their valency is same. And when we see when we move from the top to bottom of that group, we can see that number of shells. For fluorine, the electrons are distributed in 2 shells. But for chlorine, it is 3. And for bromine, here we can see 4 shells are there. We can conclude that elements in a group have same number of valence electrons. And that's why they show similar chemical properties. And the number of the shells increases as we go down the group. The second period elements when we see. The second period elements are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Here when we see, as you know that from left hand side to right hand side of the periodic table, the atomic number increases gradually. That here you can see. For lithium, the atomic number is 3, for beryllium it is 4 and for boron it is 5. Like that it is gradually, there is an increase in the atomic number. Here when we write the electronic configuration or electron distribution of these elements, we can see that these all belong to second period and these all are showing 2 shells. When we distribute the electrons, we will get only 2 shells are there in all these elements. And in a period, the number of valence electrons, when we see in a period, the number of valence electrons from the first element to last, we can see that there is a gradual increase in the number of valence electrons. For example, first element in second period is lithium. Here the number of valence electron, that is valency is 1 and for beryllium it is 2 and for boron it is 3. Like that it will increase. Period. The atomic number increases by 1 unit on moving from left to right in a period. So the number of valence electrons increases as we move from left to right hand side of the period. Left to right side of the period. The elements in a period have same number of shells. The elements in a period have same number of shells. The number of elements placed in a particular period depends upon the fact that how electrons are filled into various shells. The number of elements placed in a particular period depends upon the fact that how electrons are filled into various shells. The maximum number of electrons that can be accommodated in a shell depends on the formula 2n square, where n is the number of the given shell, first shell, second shell or third shell or so on. Here the maximum number of electrons that can be accommodated in a shell, we can find it out by this formula. For example, in K shell, the number of electrons is 2 into K shell is the first shell. That's why 1 square is equal to, we will get it is 2. And 2 elements in the first period. As you can see that, how many elements are there in the first period? Only 2 elements. What are the elements? Yes, hydrogen and helium. And the L shell can accommodate a maximum of 8 electrons. It can accommodate maximum 8 electrons. We can find it out with this formula, that is 2n square. L shell is the second shell, that's why we will write 2 into 2 square, that is equal to 8. Here in the second period, you can see 8 elements in the second period. Position of the element in the period table tells about its reactivity. The valence electrons determine the kind and number of bonds formed by an element. The position of the element in a periodic table tells about its reactivity, and the valence electrons determine the kind and number of bonds formed by an element. Here is the periodic table. And we already discussed that atomic number is denoted by Az, and it is equal to the number of protons in the nucleus of an atom. The modern periodic table has 18 vertical columns known as groups and 7 horizontal rows known as periods. And the position of an element in the periodic table tells us its chemical reactivity, and the valence electrons determine the kind and number of bonds formed by the element. Here is one question for you. A student studying modern periodic table arranges some elements in different groups as shown. You can see the group 1, group 2 and group 18 are given. You can see the elements in it. Okay, now the question is, which group supports the guidelines of the modern periodic table? Which group supports the guidelines of the modern periodic table? Group 1, group 2 and group 18 are given. And the question is, which group supports the guidelines of the modern periodic table? Okay. The options are group 1, group 18, group 1 and 2, and option D is group 1 and 18. Okay, now we'll see the correct answer. The correct answer is option D, that is group 1 and 18. Which group supports the guidelines of the modern periodic table? The answer is group 1 and 18. Group 1 and 18. Next question. The image shows an element with its atomic number and mass number. Which option arranges the element in the periodic table? Here it is given phosphorus, and its atomic number is 15 and mass number is also given. And which option arranges the element in the periodic table? The options are given. Option A, group 1 period 1, or group 5 period 3 and group 10 period 1, and option D is group 15 period 3. Which option arranges the element in the periodic table? Okay, now we'll see the correct answer. The correct answer is option D, that is this element belongs to group 15 and it belongs to period 3.